Welcome to the class. Today we are going to start with the third unit of your syllabus, that is Cathode Ray Oscilloscope. And believe me, it is the most interesting unit of your syllabus. So let us begin. Cathode Ray Oscilloscope. That is lecture 1 of it. So, as our tradition is, why this particular topic is placed on your syllabus, we generally begin with this question mark why? Why CRO? So here I am putting a question to you that if there is a multimeter which can determine the frequency of your signal, the voltage of your signal, and functions like that, then what is the need for CRO? हमको CRO की ज़रूरत क्यों है? So one reason for that is sometimes you need to see the exact waveform. Sometimes you need to see the exact waveform your device is producing. Sometimes you want to clip a particular part of your waveform, like you don't want the waveform for this half of the period. So you can clip it only by looking at it. So you need the exact picture of your waveform at every instant of time, which is not possible in case of multimeter, because multimeter gives you the RMS value generally of voltage when you measure the signal across it, but sometimes you need the instantaneous value too. You need values of voltages at every, or current or amplitude at every instant of time. So multimeter is a very good device, but certainly it has its limitation, and hence there is the need for CRO. So one of the basic functions of electronic circuit is the generation and manipulation of electronic wave shapes. So electronic signal, why you need to modify your electronic signals? Because they represent audio information. I'm speaking, and if my speaking is converted into my voice is being converted into a waveform, so if I want to clip in particular thing, so I need to see the full wave that is produced by me. Computer data, television signals, timing signals, and so on. So oscilloscope displays the exact waveform, and the viewer can decide what to make of the various readings observed. So it gives you the more freedom, it gives you the more liberty, and human loves more freedom and more liberty. So that is why CRO is something common to every college lab, every institute, educational institute, science-based educational institute lab. CRO is such a wonderful thing. It provides a visual presentation like in television screen. It is just like a television screen. The visual presentation of any waveform that you apply to your input. So here the point is given, what I emphasized few minutes back. Multimeter provide numeric information about an applied signal. The oscilloscope allows the actual form of the waveform to be displayed. Second is, a CRO may be built to operate from a few hertz up to hundreds of megahertz, but with multimeter at the extreme ends of frequency, it gives a large amount of error, है ना? So when you go for very higher frequencies or very lower frequencies, there are deviations, much larger deviations from the actual value in case of multimeter, but CRO in that case comes to our help. So CRO is such a beautiful device. Also, we can measure time spans from fractions of nanosecond. You can imagine fraction of nanosecond. Nanosecond is already 10 to the power 5, and uska bhi some fraction 1 upon n to many seconds. So the flexibility it gives, the liberty it gives, the freedom it gives is priceless, and hence it is the part of your syllabus. So that is, we ended up with a why question. Now coming directly over to the topic, that is cathode ray oscilloscope. What is it? How it works? What is the circuitry involved? And all such things we will be dealing in this particular lecture. Cathode ray oscilloscope allows the amplitude of electric signals. Electric signal can be displayed as a function of time, है ना? टाइम के हिसाब से हर एक इंस्टेंट पे क्या वैल्यू है, यू कैन डिस्प्ले इट, एंड इट डिपेंड्स ऑन द मूवमेंट ऑफ इलेक्ट्रॉन्स. As the name suggests, cathode, what does the cathode mean? Cathode rays are what? Just beam of electrons. So it works on the principle of the movement of an electron beam. So what happens is, an electron beam is impinged on a target on a screen. So they are high energy moving electrons. When they hit the screen, energy is being transferred to that screen, and that screen started glowing, and that glow pattern you observe on your screen. तो जहां जहां हिट करेंगे, जिस मूवमेंट से हिट करेंगे, वही मूवमेंट आपको visible होगा on the screen. So that is being written over here. It depends on the movement of electron beam, which is bombarded on a screen coated with the fluorescent material to form a visible spot. So just a brief idea here. Each and everything we will be dealing in the subsequent lectures of this unit. So now if this is the screen, and if the motion is horizontal, you can imagine in two-dimensional plot, imagine that the screen is towards you, so the spot can move. This is the spot. At this point, electron beam is hitting. So if the electron will move this side or this side, this is horizontal axis. But if the electron beams move up and down, this is the vertical axis. So here on screen you can get actually the 2D plot, two-dimensional plot of your waveform display. So 2D plot can be easily obtained. Now the question comes, how this electron beam will move here and here. So you can imagine this is a charge, this is an electronic charge. So electrons can move when there is some kind of electric field around it. So if here is, this is electron, this is the spot on the screen where the electrons are hitting, but at the back of it, if we apply some positive voltage here, this spot will move to this side. Similarly, we allow some positive voltage here, this will move to this side. So by manipulating with the electric field, you can manipulate the movement of charge. Okay. Now also remember one thing, that here I will draw a comparison we did in conventional multimeter with the CRO. So in conventional, what happens is, this is a coil and you pass a current through it. This coil rotates and the needle attached to it moves. So the needle movement is directly proportional to the current. Understand this point. Linearly proportional, important. Linearly means एक गुना करंट को चेंज करेंगे तो एक गुना ही इस नीडल का मूवमेंट होगा, तभी तो आपको एक्यूरेट वैल्यूज मिलेंगी, तभी तो आप कैलकुलेट कर पाओगे. एक्सटेंसिवली वी हैव कवर्ड इट इन यूनिट 1 कि why the linear dependence is crucial to the working of multimeter. If there is no linear dependence, we will not be able to calculate it. ठीक है, तो लीनियर डिपेंडेंस के लिए यू नीड कि जितना आप करंट इसको सप्लाई करें, अकॉर्डिंगली द नीडल शुड मूव. ऐसा ना हो कि करंट आपने एक गुना ही बढ़ाया है और ये 2 गुना बढ़ जाए. ऐसा ना हो तो whole calculation will get disturbed. Every time there is a different sort of movement and the values you get different at different instance will be different. So there has to be some standard working of a device, standard formulas for a particular device, which it should follow at every instant. On every day you take measurements with that. So that is the case. Similarly here, यहाँ नीडल तो नहीं है CRO के केस में, यहाँ पर है आपका कैथोड बीम ऑफ इलेक्ट्रॉन्स है, तो बस यही मान लो इंस्टेड ऑफ नीडल देयर इज अ कैथोड रे। तो ये कैथोड रे का जो मूवमेंट है ऑन द स्क्रीन, दिस मूवमेंट, this should also be proportional to the voltage applied in the CRO, applied to the CRO, जो भी वोल्टेज आपको मेजर करनी है। और फिर जब सपोज लेट्स से आपने उसको 1 टाइम इंक्रीज किया या 2 टाइम्स इंक्रीज किया, तो ये मूवमेंट भी दुगनी होनी चाहिए, तभी तो प्रोपोर्शनल मूवमेंट हुआ, तभी तो प्रोपोर्शनली यू कैन मेजर थिंग्स। सो दिस इज इंपॉर्टेंट। Constant rate, the beam is deflected at a constant rate relative of time along the x-axis and is deflected along the in response to a stimulus such as कोई भी stimulus हो, voltage हो, current हो, some kind of energy you have to give to move the electron beam. So this produces a time dependent variation of input voltage. So emphasize this point. Constant rate relative of time, constant rate से vary करना चाहिए, let it be squared, let it be linear, but it should be constant, so that जो हमने formula, जो methodology devise करी है for the device, it should stand out in every case. ठीक है, so this is the thing to be emphasized upon. Now you can also call oscilloscope as an electron beam voltmeter, because instead of needle here is what, electron beam, बाकी तो it's similar. Now there is a particular reason for choosing electrons, है ना, कि we choose particularly electrons. ऐसा नहीं है कि proton, if you will strike on a target, they will not heat up or they will not produce energy on the fluorescent material. It's not like that, but there is a particular reason for the electrons. First, it is easier to knock out electrons, and the second electron has practically no weight. 9.1 into 10 to the power minus 31 kilogram. And this is the order. And proton, for proton it is 1.6 into 10 to the power minus 27 kilogram. Although you can say it is also very small, 10 to, but in comparison to electron, it is 1000 times heavier. 1000 guna bhari hai. 1000 times heavier. It is a lot. 1000 times heavier. Okay. So this is the thing. So electron has practically no weight, and when there is no weight, there is no mass, there is no inertia. जब inertia नहीं होगा, तो since this is electron beam, तो आपने जब energy इस इधर लगाई तो फटाफट से ये इधर मूव कर जाएगा, इधर लगाया पॉजिटिव फील्ड तो इधर मूव कर जाएगा, लेकिन अगर इनर्शिया होगा इसमें तो इट विल टेक सम टाइम, देयर इज अ टाइम लैग. So that is the case. So no inertia, therefore the beam of electrons can be moved to follow waveforms varying at a rate of millions of times per second. They move very quickly, so the pattern you get on the screen is instantaneous. Electron beam faithfully follows rapid vibrations in signal voltage and traces a visible path on the CRT screen. So this is the thing. Also, it is electronic in nature. Electronics we have dealt in great detail in second unit. So if you want to know more about it, please look at it. पूरा electronic है. Electronic devices are being built up into the semiconductor. So it can also easily produce reproduce, not produce, क्योंकि वो अपने आप तो कोई वेव क्रिएट नहीं कर रहा ना. CRO में तो जो आप डिवाइस कनेक्ट करोगे, जो भी डिवाइस आपने कनेक्ट किया है, उसकी वेवफॉर्म, उसकी एनर्जी को वो बस पिक्चराइज करेगा. सो इट जस्ट रिप्रोड्यूस, नॉट प्रोड्यूस. हाई फ्रीक्वेंसी वेव्स टू. So high frequency waves are very much required when you are dealing with communications, and when you are dealing with transfer of information from one place to another, transfer of data. So it has simplified a very practical utilities. It has simplified to test the circuits. किसी circuit में कोई खराबी हो गई है तो easily you can see on the CRO where there is an error in case of this high frequency, and you can get it done correct. So this is one benefit of this. So in conclusion, we can say it is a kind of voltmeter which uses beam, instead of a pointer, and a kind of recorder which uses an electron beam instead of a pen. Because in the later part of the lecture, you will also learn about digital storage oscilloscope. Okay, digital storage oscilloscope. So it can store the graph you obtained on the screen. So if you go the next day to the lab, you need not to design your whole circuitry again. You can just go to that storage mode and see what I have done yesterday. So it also records, it also stores the modern advanced one. Okay, so you can call it a voltmeter, which is a beam instead of a pointer. So we are proceeding exactly in the same way as the syllabus defines, and it is also very methodical. पहले हमने why पढ़ा, फिर हमने उसका introduction पढ़ा कि broadly what are they. Now specific components, block diagram you can see of CRO. But before that, let me show you the figure. This is the simple block diagram of your CRO, and with each we will deal in great detail. So here you can see, first part is display. In modern oscilloscope, it is usually LCD panel, the LCD TV you also see in your homes. In old oscilloscope, the display was a cathode ray tube or CRT. Old, और जो हमारे कॉलेज की लैब में है, they are CRT based. Display is laid out with horizontal and vertical reference lines referred to as graticule. There are lines on the like 1, 2, 3, है ना? So that when you reproduce a wave, so you can measure what is the voltage, है ना? What is the time period of the wave. So small divisions are there, both horizontal and vertical. ठीक है? So this is your display. You can see here you see the movement of electron beam or your graph, etc. So this is simple, nothing much in this. Next is cathode ray tube. This hole is known as cathode ray tube. Here there is a cathode. When you supply energy to it, it knocks off electrons. Those electrons move towards the screen. We will deal it within great detail. CRT is a specific mention in your syllabus कि CRT के अंदर काम कैसे होता है, and it is a main component of CRO. ठीक है, but for the time being, have patience and just go through the components. So a rough idea I have given you. This is a metal plate. On supplying energy to it, electrons are being knocked out. Then those electrons hit the screen, and here you get the CRO. Oh, sorry, display. Fine. Vertical amplifier. Now here you can see, this is the vertical amplifier. You supply input, but if input is too small कि वो आपको स्क्रीन पे दिखेगा ही नहीं, जो उसका एम्पलीट्यूड है वो बहुत छोटा है, suppose it is of the order of 0.01 volts, हाँ, और 1 millivolt, very small magnitude, तो आपको ग्राफ में कुछ ऐसा something like this instead of like this. So such small measurements, you're not able to make it correctly. So amplifier just amplifies the input signal if needed. ठीक है? It amplifies the signal waveform to be viewed. Now similarly there is a horizontal amplifier. So now let me make it clear. This is your electron beam. So you need to move it left and right. You need to move it back and forth, up and down also you can see. So there are two voltages applied on this input signal. एक ऊपर और नीचे, इमेजिन इट इन 3D, ऊपर एंड नीचे, अगर इलेक्ट्रॉन बीम को ऊपर नीचे मूव कराना हो, और एक आपके लेफ्ट और राइट, कि अगर इलेक्ट्रॉन बीम को लेफ्ट और राइट मूव कराना हो, सो देयर इज अ वर्टिकल इनपुट, देयर इज अ हॉरिजॉन्टल इनपुट, तभी तो आपको 2D प्लॉट और सम एलिप्स काइंड ऑफ थिंग और सम 2 डायमेंशनल थिंग मिलेगा. So understand it very carefully that electron beam is movement of electron beam is managed by inputs at horizontal plates of the CRO and vertical plates of the CRO. So both the cases we need amplification. if अगर voltage बहुत कम होती है तो उसको बढ़ाने के लिए, और अच्छे से अभी समझ में आ जाएगा when we will be dealing with the block diagram of CRT. So you can see both the वर्टिकल एम्पलीफायर से भी सीआरटी में इनपुट जा रहा है, क्योंकि यहाँ क्या है, बीम है, और हॉरिजॉन्टल एम्पलीफायर से भी जा रहा है. तो इस बीम, जो भी वोल्टेज आप लगाओगे दोनों पे, हॉरिजॉन्टल पे और वर्टिकल पे, वो दोनों ही इन इलेक्ट्रॉन्स को इफेक्ट करेंगे. ओके, नाउ दिस डिले लाइन, दिस इज इंपॉर्टेंट. यू कैन सी हियर delay line. So you can see you are supplying the input signal, and this input signal is reached to CRT through this path, and this input signal is also being divided and to the horizontal plates and being supplied to CRT. So this path it will take in case of horizontal one. So you can see this vertical path is distance is less than the horizontal one. तो क्या होगा, ये जो vertical सिग्नल है वो जल्दी पहुंच जाएगा, horizontal से पास होने वाला देर में पहुंचेगा. तो there will not be proper superposition of the two waves. तो इससे रिजल्ट क्या होगा, आपका जो मिलना चाहिए था स्क्रीन पे कोई और शेप, और मिल जाएगा कोई और. क्योंकि क्या हुआ, ये पॉइंट को अच्छे समझ. सपोज यू वांट टू सुपर इम्पोज 2 वेव्स, है ना. अब तो t इज इक्वल टू 0 पे इसका सपोज ये वोल्टेज है, और t इज इक्वल टू 0 पे सपोज इसका ये वोल्टेज, दिस इज. तो आप हमेशा यही चाहोगे ना, टाइम इज इक्वल टू 0 0 वाले मैच करें, हमेशा t इज इक्वल टू 1, और इसका भी जब t इज इक्वल टू 1 हो तो मैच करें. आप ये तो नहीं चाहोगे t इज इक्वल टू 1 वाला, क्योंकि वो जल्दी पहुंच जाएगा, और t इज इक्वल टू 0 लेट में पहुंचेगा. तो ये सुपर इम्पोज करें ये पॉइंट्स आपस में, it will give you altogether a different result. So you want कि at the same time both the signals reach. तो ये तो ज्यादा दूरी तय कर रहा है, तो इसको तो हम कम नहीं कर सकते, because it is passing to 3 blocks and they all are necessary components. Horizontal amplifier is important, trigger circuit is important, sweep generator is important, right? तो हम क्या कर सकते हैं, वर्टिकल लाइन में एक जानबूझ करके एक ब्लॉक प्लेस कर दें, ताकि वो सिग्नल उतनी ही देर में पहुंचे जितना कि हॉरिजॉन्टल वाला पहुंच रहा है. ठीक है. So this is the manipulation little be done. So hence delay line, to deliberately delay the signal in case of vertical input. ठीक है. और हो सकता है horizontal में आप same input से derive कर लो horizontal amplification वाला input, और हो सकता है आप अलग से भी दे दो इसको. Both the ways are possible. We will be dealing with it. Same भी दे सकते हो, अलग भी दे सकते हो. It depends on the CRO कि वो both the modes को support करता है कि नहीं करता है. Right? So delay line, horizontal amplification. Now sweep generator, very important. This is the sweep generator. The function of sweep generator I will be dealing in the coming lecture. जैसे हम CRO में आगे पढ़ेंगे, उस पे हम तब हम इसको डिस्कस करेंगे, then it would be more clear. Now I am not going to say a single word over sweep generator, because this is the component which drives the waveform. Waveform कैसी आपको स्क्रीन पे दिखेगी, उसका बहुत रोल है, तो वो मैं एक डायग्राम से I will try to explain you. Right? So for the time being, let us hold on it. sweep generator, ठीक है, and trigger circuit both. Now coming to this point, here you are seeing two supplies are there. एक है high tension, HT is high tension supply, and the other one is LT, low tension supply. So why high tension and why low tension? So to drive all those blocks, vertical amplifier, delay line, trigger circuits, you need some energy. तभी तो ये सारे blocks, amplifier अपने आप में तो काम नहीं करेगा. You need to supply energy. So low tension supply gives energy to all these circuits in your CRO. But यहाँ से आपको electrons knock out करने हैं from the cathode plate, है ना, cathode rod, whatever you say. So वो लो टेंशन सप्लाई से तो आप इलेक्ट्रॉन्स को नॉकआउट नहीं कर पाएंगे. तो फॉर दैट, फॉर जनरेटिंग सफिशिएंट अमाउंट ऑफ हीट सो दैट इलेक्ट्रॉन्स आर इजेक्टेड आउट ऑफ द प्लेट, यू नीड हाई टेंशन सप्लाई. आप देख भी रहे हो, दिस इज गोइंग टू CRT. So for CRT you need high tension supply to knock out the electrons, and for rest the circuit low tension supply is sufficient. Otherwise these blocks will get damaged if you supply high voltage. And the range is also given, plus 300 to 400 voltage, and this 1000 to 1500, because ज़्यादा है तो ज़्यादा रेंज डिफरेंस है ना दोनों के बीच में, तो एक सप्लाई से काम नहीं चलेगा. Now block diagram of CRO. Now on this I will come back again, block diagram of CRO. First let me explain you the working of CRT, how this CRT functions. ये CRT कैसे काम करता है, let me explain you that. Then we will get back to the block diagram of CRO. Then it will be much clear for you how the block diagram explains each and every component of CRO. So let us start with cathode ray tube in the next lecture. Thank you.